Assalamu alaikum, dear students. Today we are going to discuss magnetic dipole and its magnetic field. And you know that we have already discussed about the magnetic field lines and magnetic lines of force. Now, without wasting our time, we will start the magnetic dipole and its magnetic field. Now, first of all, we have to discuss the magnetic dipole. Magnetic dipole. The magnetic dipole, it consists of two poles of equal strength, equal and opposite poles of equal strength, but they are separated by some distance. That distance is taken as 2l. We take this distance between the north pole and south pole 2l in order to make the mathematical calculations easy. So what's magnetic dipole? It's a system of two equal and opposite poles, north pole and south pole, separated by very small distance, that's taken as 2l. So magnetic dipole, for example, a bar magnet, it consists of two poles, two magnetic poles of equal and opposite strength. Of equal and opposite strength, separated by very small distance, that's taken as 2l. So magnetic dipole is the system of two equal and opposite poles, magnetic north pole and magnetic south pole, separated by small distance, that is taken as 2l. So for example, we have examples: bar magnet, bar magnet, bar magnet, magnetic needle, or current carrying solenoid, current carrying solenoid, or current loop, or an atom is taken as star. These are the examples of magnetic dipole. Current carrying conductor is also having the current carrying solenoid, that we have discussed it already in the classroom. That current carrying solenoid, it's called electromagnet. So these are the examples. So what's magnetic dipole? A system of two equal and opposite pole strength separated by very small distance is called a magnetic dipole. जैसे मैंने ये एग्जाम्पल्स लिखे. अब now we have to, what do we mean by the magnetic dipole moment? Magnetic dipole moment. Magnetic dipole moment. Magnetic dipole moment. Magnetic dipole moment. Electric dipole moment. Already we have discussed electric dipole moment, that it measures the strength of electric dipole. When theoretically, or it measures the strength of electric dipole, it is denoted by P is equal to Q into 2L. This is about the electric dipole moment. Now here magnetic dipole, it is the product of pole strength of either pole and dipole length. इन दो पोल में से एक पोल की स्ट्रेंथ ले लो और dipole length ले लो, it is denoted by m. Here in electric field it is denoted by p. Here in magnetic field it is denoted by m. M is equal to, here, pole strength. Pole strength north pole it is m n, and pole strength of south pole is ms. But in case of dipole, in case of electric dipole, dipole is made up of two equal and opposite charges, so magnitude of charges are equal. Here pole strength of two poles are equal. जैसे इलेक्ट्रिक डायपोल में दो चार्जेस का मैग्नीट्यूड इक्वल होता है, इसी तरह यहाँ पर जो पोल स्ट्रेंथ ऑफ टू पोल्स इक्वल होती है, तो we can say ms is equal to mn, that is equal to m. So we take the magnetic pole strength as m. So dipole moment जैसे q into 2l, so यहाँ पर m into 2l. देखो, what you have to do, you have to only change the symbols here. जो आपने इलेक्ट्रिक फील्ड में पढ़ा है, यहाँ पर symbols, वहां पर इलेक्ट्रिक डायपोल मोमेंट वाज डिनोटेड बाय p, यहाँ पर मैग्नेटिक डायपोल मोमेंट इज डिनोटेड बाय m. वहां पर चार्ज q थी, यहाँ पर चार्ज की जगह स्मॉल m पोल स्ट्रेंथ, और 2l तो 2l सेम है. दिस इज मैग्नेटिक डायपोल मोमेंट. सो मैग्नेटिक डायपोल, इट्स अ वेक्टर क्वांटिटी, it's a vector quantity, and its direction is from south to north. Its direction is from south to north. Its direction is from south to north. And also what we have to discuss here, so, and its SI unit is, here SI unit of magnetic pole strength m, SI unit of m is, it is ampere meter. SI unit of m is ampere meter, and for that, for dipole moment it is ampere per meter square. It's ampere per meter square. So what's the SI unit of? It is ampere meter. And what is the what is it that for this moment? It is ampere meter square. So for it is ampere meter, and SI unit of capital M is ampere meter square. So that usually we write from this ampere meter square in case of current loop as a magnetic dipole. Here dipole moment m is equal to I into a. I का वैल्यू एम्पियर है और a है मीटर स्क्वायर, तो m का बन गया एम्पियर मीटर स्क्वायर. सो दिस वी कैन, किसी को डाउट मत होगा तो वो क्लियर करें. यहाँ पर देखो, ये आगे हमें पढ़ना है. m is equal to I into a, करंट लूप में I into a. So m, it is m is इसका यूनिट, इसका एम्पियर हुआ, और a एरिया मीटर स्क्वायर, तो एम्पियर मीटर स्क्वायर. अब ये जो m है इट इज m into 2l. देखो m into 2l. सो स्मॉल m, 2 को छोड़ो, हमें यूनिट से गरज, हमें यूनिट देखना, एम्पियर मीटर डिवाइड बाय दिस l इज मीटर एंड मीटर स्क्वायर में से मीटर, सो m का हुआ एम्पियर मीटर. तो इसको जूल पर टेस्ला भी कहते हैं, इसको हम कहेंगे जूल पर टेस्ला, या हम ऐसे भी कहेंगे जूल पर टेस्ला और जूल पर टेस्ला. दिस इज अबाउट द यूनिट ऑफ magnetic dipole moment and magnetic pole strength. So we were discussing this. So magnetic dipole moment and magnetic dipole. Now we have to discuss the Coulombs law in magnetic field. What's the analogy of Coulombs law, and is Coulombs law applicable here? Yes, it is applicable. Coulombs law is applicable here. So let us suppose we have a magnetic dipole, north pole and south pole. So यहाँ पर क्या है, पोल स्ट्रेंथ, इसकी पोल स्ट्रेंथ mn and इसकी पोल स्ट्रेंथ ms. So according to that is magnetic force between north pole and south pole, that will be k times mn into ms divided by, let's suppose this is d distance, so d square. d square. So here k is equal to mu 0 by 4 pi. So FB becomes mu 0 by 4 pi mn into ms divided by d square. We know magnitude in terms of mn is equal to ms, so you can write it for magnetic dipole. It will become mu 0 by 4 pi m square divided by d square. So same is the case force between two charges in dipole. F is equal to k q1 q2 divided by r square. So here F is equal to k is 1 divided by 4 pi epsilon in electric force, and this is for dipole q1 is equal to q2, so you can q square divided by r square. So it means only you have to change the symbols. Here you will write for charge you write q, for magnetic pole strength you write m. Here 1 by 4 pi is electrostatic force constant, so magnetic field constant mu 0 by 4 pi and r square. This is analogy, and जैसे इससे पहले हमने देखा here m is equal to m into 2l for dipole moment, and here p is equal to q into 2l. So what you have to do, you have to इसमें हमें वही रिपीट करना है जो हमने इलेक्ट्रिक फील्ड इलेक्ट्रिक डाइपोल में पढ़ा है, सिर्फ हमें सिंबल्स को चेंज करना है. इसलिए मैं थोड़ा जल्दी इसको पढ़ा रहा हूँ, क्योंकि ऑलरेडी ये इलेक्ट्रिक फील्ड्स में और इलेक्ट्रिक डाइपोल में पढ़ा है. तो दिस वाज अबाउट देम. अब हम आते हैं किस पर? सो मैग्नेटिक फील्ड ड्यू टू मैग्नेटिक डाइपोल. नाउ ये भी आपने already this has been discussed in there. For example, we have this is a Bohr magnet. This is a Bohr magnet, and this is magnetic south pole, and this is magnetic north pole. So what? जैसे हमने वहाँ magnetic field, electric field at the axial line of electric dipole. Let's suppose this is point P. You know, we had to find magnetic field at the axial line. Magnetic field at axial line of magnetic dipole. Consider a magnetic dipole, a Bohr magnet. We consider a Bohr magnet, we take a Bohr magnet and let P be the point at the axial line. We know axial line is line passing through the center of the two poles, and it's a horizontal line. So we take a point P at a distance, this is center O, we take point P at a distance R from center O of the magnetic dipole, because everything we have to calculate, whether it is the electric potential of dipole, whether it's electric field of dipole, we have to take it from center. So this we know this Bohr magnet is of length 2l, so यहाँ तक आएगी distance l and यहाँ तक आएगी distance l. So ये हुई distance 2l. Now this is point P, which is at a distance r, and this is NP and this is NN. So what we have to do, we have to magnetic field at point P due to north pole. Magnetic field at point P due to north pole, that will be Bn. That's Bn. वहां पर E पॉजिटिव चार्ज से पहले, यहाँ पर Bn, that is mu 0 by 4 pi, और वो फील्ड डिपेंड्स अपॉन द सोर्स, जिस सोर्स चार्ज वहां पर चार्ज, यहाँ पर वो सोर्स. फिलहाल हम नॉर्थ पोल की बात करेंगे, इसको नॉर्थ पोल स्ट्रेंथ mn, but we take mn is equal to ms, so we take m divided by what is distance between north pole and P, that's np square. And let us suppose here is unit north pole. Here at point P there lies unit north pole. So now this north pole will repel this north pole, and the direction of field will be along this direction, that's positive x-axis, positive I cap, that's x-axis अगर positive direction में हो तो x I cap, अगर इस direction में हो तो minus I cap, अगर ऐसे direction में हो तो j cap, अगर इस direction तो minus j cap. तो यहां पर ये वहां जाता है तो इसका आएगा आई कैप, आई कैप। तो डायरेक्शन दैट इज बी एन इज इक्वल टू म्यू 0/4 पाई, एंड यू नो दिस इज m, व्हाट्स एन पी स्क्वायर। बट मैंने आपको इससे पहले कहा था कि वी हैव टू कैलकुलेट दी एवरीथिंग, वी हैव टू कैलकुलेट फ्रॉम सेंटर। सो एन पी स्क्वायर, एन पी इज इक्वल टू ओ पी माइनस ओ एन, दिस इज यहां पर सेंटर है ओ पी, that's this is OP, so NP is equal to OP minus ON, but this ON is N, so we can write this NP is equal to OP, that means R, OP is R, that's R, minus ON is L, R minus L whole square, and I cap. This is the magnetic field at point P due to North Pole. Now magnetic field at point P due to South Pole. Magnetic field at point P due to South Pole. So South Pole से क्या आएगा? South Pole से आएगा BS. That will be mu 0/4 pi. Similarly, M divided by. But this is S. S is OP plus L. That is R plus L. So R plus L whole square. And it will be along negative axis minus I cap, because South Pole will attract this North Pole, so the direction will be, force direction of this field will be along this direction, negative. So BS will be equal to mu 0/4 pi, mu 0/4 pi M divided by R square plus L square, and it will be minus here, and this will be I cap. So this is about, this is equation second. This is equation second. So what we have to do now, we have to calculate the total field. Total field due to the magnetic dipole. Total field at point at P due to dipole. That's B, total B is equal to Bn plus Bs. So B is equal to, what's Bn? That's mu 0/4 pi. Mu 0/4 pi M I cap divided by R minus L whole square, and this is minus mu 0/4 pi M R square minus L plus L square into I cap. So here B is equal to mu 0/4 pi common, M I cap common, and it will be 1 divided by R square minus L square minus 1 divided by R square plus L square. So this will be equal to, B is equal to mu 0/4 pi M I cap, and this will be R square plus L square cross multiplication minus R square minus L square, or minus L or plus L whole square, or minus L whole square divided by A minus B, A plus B, A square R square minus L square whole square. Oh, I'm sorry, it's not R square L square, it's whole square, and here it's whole square. तो यहाँ पर अब ये R square plus L square whole square and minus R, it is 4RL. You can calculate it by using A square plus B square plus 2AB, A square plus B square minus 2AB, and you will get the result here. B will be equal to, B is equal to mu 0/4 pi Mi into 4RL divided by r square minus L square whole square. This is the magnetic field at point P. So we can convert it in terms of magnetic dipole moment. So what we have to do now? So this B is equal to mu 0 by 4 pi, and this m into 2 Li into 2r divided by r square minus L square whole square. So B is equal to mu 0 by 4 pi, ठीक है 4rl को मैंने 2l into 2r करके लिखा, 4rl is equal to 2l into 2r. So mu 0 by 4 pi m और I कैप को यहाँ रखा 2l, m into 2l अभी डाइपोल मोमेंट हो गया मैग्नेटिक, दैट्स कैपिटल M, और I कैप वेक्टर कैपिटल M. So this is m और ये I कैप मिला के वेक्टर 2r divided by r square minus L square whole square. This is the magnetic field at axial line of magnetic dipole. Magnetic field at axial line of magnetic dipole. So already this मैंने थोड़ा जल्दी की इसलिए कि already हमने इस चीज को इलेक्ट्रिक फील्ड में पढ़ा है. तो यहाँ पर क्या है, अब if the dipole for short dipole L tends to 0, so R plus L, R minus L will approximately equal to L, or R minus L will approximately equal to L. This will be equal to R because L is very small. So B will become mu 0 by 4 pi twice M R divided by, when this L is 0 this will become R4, and 4 में से एक निकालो तो मैग्नीट्यूड B is equal to, चलो मैग्नीट्यूड की बात करते हैं, mu 0 by 4 pi twice m divided by r cube. ये वही है बिल्कुल. अगर आपको एक्सल लाइन का इलेक्ट्रिक फील्ड याद होगा, that was 2p divided by r cube, and यहाँ पर 2m divided by r cube. This is only you have to change the symbols. What you have to do? Only you have to change the symbols. Similarly, when you go for the equatorial line, field, you will get the result will be B equatorial will be, that will be mu 0 by 4 pi m divided by r cube, because equatorial line का फील्ड हाफ ऑफ एक्सल लाइन फील्ड होता है. तो जैसे उसमें, and only you have to change the symbol. Instead of q you have to write the small m, instead of p you have to write the capital M, and this will change. Instead of electric field E you have to write the B. So you have only changed the symbols here. So hope you will do these things at your home, and we will move towards the question that is the very important question, that is torque on magnetic dipole in uniform magnetic field. That's torque on magnetic dipole in uniform magnetic field. So जैसे आपने पढ़ा है इलेक्ट्रिक फील्ड में torque on electric dipole in uniform electric field. So this question is asked in board examinations. So we will discuss, and we will also discuss numericals on it. That will be inshallah in next lecture. Thank you.